Hi all, welcome to another episode of Saturday Architecture. We have Janaka, who's a CTO of a large IT services org in Colombo, Raja, who's a architect with Standard Chartered, Venkat, who plays the CTO for AquaConnect, a startup, and Deepak, the architect with Microsoft Services. What we wanted to talk about is Ulrich Hohmann, my mentor in Microsoft. I've learned a lot of things from him. He done a recent video on resilience and uh, redundancy and self healing. And I think that kind of triggered back memories, and I thought it's worth talking about when we talk resilience. So, one of the things which says resilience is about keeping services running, and resilience doesn't mean that the entire application to be resilient. And in the microservices world, if we start looking at capabilities and you split the application into multiple business capabilities, there'll be only few capabilities which needs to be really resilient. Okay. And if we can separate that, you start at the business layer, find out what business functionality needs to be resilient, support that with a good microservices architecture in a true sense, and then in today's world we can leverage cloud services again, which helps you take it even further. And the beauty of this thing is all these can be done at a pretty low cost. Consider if I had to do this 15 years ago, right, it would have been so expensive to do something like this. So let me share one example. So I have a simple application where people have to journal what they are doing, and then there is another part where they see a scoreboard of what they have done. They click that, they'll give a scoreboard. Okay. So one thing which in this case, what I realized is people doing a journal has to be really resilient. So when they come, they say, I have done that, that should be there. But the scoreboard needn't be really resilient. So luckily, once I was able to identify this, what we have done is that the journaling part runs on one server, right? That is one capability. Seeing the scoreboard is a completely different capability. If they don't see the scoreboard, it's okay. They can come back later and have a look at it. Now, that runs as a separate service. In an older age, right? Like probably 10 years ago, I would have had to have a different server running the reporting server with its own DB and things like that, move data from here to there, kind of a thing, which would have been expensive, but still it would have been resilient. Now, with cloud services, I can actually consume a hosted cloud service. Now, what has happened because of that is that even if that reporting services is down, my application doesn't get overloaded. So I get resiliency there. And second side benefit, which I realized as I was telling that is it's pay per use, right? So unless somebody clicks a report, I really don't have to pay for that. In the previous day, that report server, which I was running separately, I would have had to pay for it. Now, today, unless someone clicks on that report, a request is not going to go to that third party service and I won't be billed for it also. And even if that service goes down, my core functionality is still up because they are clearly separated boundaries. So resilience can be achieved without. So previously, okay, the point is resiliency is not expensive in today's world. It can be offered at a much significantly lower cost, not just marginal lower cost, significantly lower cost, if we look at it from that business perspective. So reporting services, move it out, it became cheaper, and my core functionality, right? Now that is very simple. People come in, say, I have done this and go out. That's the core functionality. For that, I don't need to spend so much to give that resiliency. Janaka, have you had, and in your experience, right, in some app, have you been able to identify something like this?
Yes, Komaran, thanks. So, first of all, when we talk about resiliency, that is something that you have to build into the solution that we are building. For each service needs to have that resiliency aspect also covered. For example, when you are building a microservice or a service in general, we have to understand what is the level of resilience that we are going to give. Because, for example, in a banking app, for example, the service that fetches the balance needs to be more resilient than the one that is giving you the transaction history or printing the what do you call the last month statement. So whenever we are building those services, that we have to keep in mind what is the criticality of it. Does it, if this service breaks, what is the what if this service becomes faulty or sick, what is the level of service that the guy who is calling us is going to get? Is it
Customer
going to
impact.
be, yeah, absolutely. So every service has a customer, right? Consumer, producer, that kind of thing. So any service that, for example, if you classify them at a very high level, if a service breaks, it can actually ask the invoker or the consumer to break its workflow if it's ultra critical. The second one is, for example, like I said, the login process, right? If the login process is not working, this is not, application cannot continue. So you make it as resilient as possible. The second one is you have a standard way of responding, saying that so that the consumer can identify that this service is currently not available. And then you build your service, what you call circuit breakers and all these patterns. The third level is you say, okay, you don't let the consumer see that there is something wrong. Instead of that, what you do is you have a cached, you give a cached solution or cached response or whatever, and you internally you manage it. So these are like levels of resiliency that you have to build in as a technical non-functional requirement into each service that you think of. So that is the first part. And the now where it gets complicated is now when you talk about microservices, we have that two big paradigms. One is the orchestration and choreography, right? With orchestration, it becomes easy because you have one single point where who actually manages all the calls, and then you can look at how the services are behaving. But when it comes to choreography, it becomes complicated because the thing is, in choreography, you go with the assumption that everybody will do their job. So it becomes more complicated because you have to add the concept of a compensating transaction each time a resiliency based error comes into play. So basically what I'm trying to say is resilience is something that you have to build in as a technical non-functional requirement, similar to log streaming or auditing capabilities. And this is something that we have to inculcate in all our services because it is a feature that is not needed until something goes wrong.
So
And
in your apps, were you able to, can you give some examples of, in this kind of an application?
yeah,
This one I made it in, like, you gave a couple of categories, right?
yeah, absolutely. So basically, now in one of my engagements, we were tasked with we had a large SOA-based solution, banking solution, which has the, what do you call, I think over 1 million lines of code, right? And the problem with that was there were about 500 to 600 different third-party calls that are going out. And back in the SOA days, we didn't have the concept of choreography. It was always orchestration. So one service breaks, the whole application comes to a standstill. The problem, Kumaran, with all this, why we need resilience is because not when a third-party service is broken. When the problem is when a service is slow, it basically chokes the consumer because the thing is you have to maintain all the threads and the memory and the resources until this guy responds, right? So that's where I think we can talk about circuit breakers in a different what do you call video. So what we did was, Kumaran, so we were tasked with coming up with a resiliency strategy for the application. So what we did was we looked at the 80% of the most critical features that kept on failing. Like, for example, every first Saturday of the month, there was a third party which does a maintenance between 4 to 6 on a Saturday.
Okay.
So the problem was the moment it doesn't go down, that third party doesn't go down, it slows down. The moment it slows down, everybody who starts to work on a Saturday morning, start paying bills, they get affected, right? But the problem is, since it's a monolith kind of application, even the people who are coming to check the account balance can't do anything, can't log in, because we are fetching everything in the landing page, right?
Okay, okay. Ah, okay.
So,
Perfect. Yeah.
so what we did was we looked at them and we came up with a template where we say, okay, for each of these service, what is the resiliency strategy we are going to take? So that's where the, what do you call, my previous template came into picture. So we looked at saying, okay, look, for these set of services, consumer cannot continue. They have to break. That's what it is. Then that is the immediate, what do you call, the tactical solution. The strategic solution is to figure out how to rationalize, give more resources, etc., have different conversations about
So it's
SLA.
interesting in this case, if I get it right, the homepage probably gets some data from the third party to show there, like something like points, could be points,
Absolutely.
right? Payback
It was
points kind
actually
of a
points.
thing.
Yeah, you're right.
Okay. So typically that's where and that just that one field we could and what did you do? You cached it, or how did you handle that so that
No,
it doesn't
because,
wait on the method? And
so the thing is, it's like this, for those kind of things, we looked at it and said, okay, this is not required at this point in time. We just gray it out if it's not there.
okay, got it.
And with a tooltip that says, this is not available at this point.
Simple. Okay. So yeah, I think that's actually pretty neat. You're not even caching, because caching complicates it further.
No, because the problem with caching that kind of things is that will give a different idea to the customer.
Yeah, that's true. Correct.
So
good call. Yeah, that's true.
So,
and
some of the things where it becomes very critical, Kumaran, the thing is, you break the workflow, because there are certain things you can't, because for example, account balance, if that is not available, the thing is, we actually did a different approach to those kind of things, where we gave the customer the capability to proceed without that component.
Okay.
Because that service is not available at that point in time.
Got it. Okay.
So likewise, basically the whole experience comes with that classification. The moment you start classifying, then you realize when you are building each service, what happens if this goes down.
Okay.
So
that I have a counter example of what cloud can do to your services, right? So this is when you move from your on-prem world to the cloud world. You need to, so this is the counter example is in the on-prem world, you are designing for success. In the cloud world, you have to design for failure. Means you have to assume things will fail, right? And actually, I worked with a customer who actually had a lift and shift operation of their on-prem SQL server to, they started using SQL Pass, right? And SQL Pass has its own latency, right? It is completely different from what you have two machines lying like few meters apart and talking to each other. And when you go to the cloud, they will not respond in the same way as you would expect in your on-prem world, right? And that is where the design for resiliency, simple thing like doing a retry, right? That the service may not be exactly available at this point of time, but it will come back in few milliseconds if you try again, right? And that is something which the on-prem developers were not familiar with. This is, I just expect the service to be there. Why is it in there, right? And the response time, why is it slower than what it is in the on-prem world? So that is what I'm saying. In the cloud world, you have to assume that things will fail. And how does your developer work with at the lower level itself? I'm not even talking about the microservice level failure. I'm talking about certain dependencies timing out, right? How do you make sure the timeout is factored in your resiliency design at the individual programmer level? That itself becomes a big deal when you go to the cloud. Although cloud gives you so much flexibility, but it also adds this layer of complexity, which now has to be thought about. It's not that you could not have done that on-prem, right? But on the on-prem world, we were made so used to quote unquote reliability at that stage, right? Which is you have clusters, you have everything, you have backup of the backup of the backup, and and that is what we were told to build our applications on, right? And now you take them to the cloud world and says, oh, I'm sorry, things may not be as reliable as they were used to be in the on-prem world. So think about it and take care of it. So I think that is something which the architects need to maybe think about, that cloud doesn't always mean that your service is by default going to be working the same way and the same level of reliability what it used to do in the on-prem world.
No, I agree with what Deepak said, because I think you have to always plan for failure, because I mean, the thing is, failing fast and failing gracefully is basically what it is. Because I also agree with what Deepak is saying, because it's about that, how that resiliency or fault tolerant strategy is panned out, because whether you retry, you wait for 10 milliseconds and try again, or just you simply say no based on what it is. Like, for example, if it is something that is fetching everything from a database, I wouldn't say don't retry. You just wait and do it, because you have 10,000 people retrying. It'll consume so much credits on the cloud environment. But again, that's why I said, Kumaran, I think one of the key things is that this resiliency should be part of the technical NFR, because the same way we have audit capabilities, right? Because we basically say when we are going a service,
I think there shouldn't it start at even at a business level. The business should say, this should be there. I would say it is more like in fact, like, probably I'm a little uncomfortable with the word NFR itself, right? Because it's like non-functional requirement. No, it's a very functional requirement. I don't even know why we see. Seriously, I discourage people from using the word non-functional requirement. No, it's a functional requirement. It has to work. How is it non-functional?
Resiliency is definitely functional.
It is a functional requirement, right? And I think at least in the ISA world, we call that as quality attributes, right? Which is much better than non-functional, because the moment you say non-functional, right, mentally it's like, hey, it's not that important. Okay, it's non-functional. No, you have to be worried about functional stuff only. Non-functional things, why are you worried about? It's anyway non-functional.
The other responsibility.
Hold on. I want to correct you there. If you are serious about building solutions, to me, your non-functional requirements are more important than functional requirements.
No, I'm telling non-functional is actually functional. I'm telling the
word terminology is wrong.
Terminology, that's all. That requirement is correct. I'm not telling the requirement is wrong, but I think we should call them as something quality so that people give more importance to it. Because you call the business and then say, I'm going to discuss NFR, and say, not my problem. Mentally, they are switched off. Because for them, it is non-functional. What is functional to me, you tell. Don't discuss your problem with me. But whether a checkout service is important or not, it is the business who can tell us how much of resilience is needed. As tech teams, I cannot take that call.
Okay. I think one more responsibility which the architects need to get is, you see, how do you come to a conclusion, this is important, this is not important? It has to come from the user experience, right? How well does the architect understand the user experience? That is what is going to decide whether this service should be resilient or not resilient, etc.
I think, Janaka, the example that you just shared some time back, right? Okay, in one of the government projects I worked, there was a similar problem that in government services, especially, a lot of poor people leave their work to come and get a job done. So if the application is slow, they lose a day's wage.
Absolutely.
Okay. But as a technical guy, for me, a process taking another 3 minutes is not too much of a difference. Absolutely. But when there are 50 people in a queue, it is 2 hours delayed for the person who is last in the queue. And if the person gets delayed by 2 hours, that individual laborer loses a day's wage, which means his family has to go hungry. As a technical developer, to me, hey, what? It's just 3 minutes slow. That's all. But so probably a government officer will actually say, my dear Kumaran, it is not 3 minutes slow. It is one family going hungry for one whole day.
Kumaran, I think that's a very good example. I'll share something even bigger than that. Something that was shared by one of my mentors and clients back in the day when I was doing low value, high volume cross-border payments, right? So we didn't have resiliency those days. It was just failure, right? So we do, for example, bulk pension transfers for European Union-based countries, right? So for us, like you mentioned, the file didn't go through. And my mentor would come and say, Janaka, you have to be respectful about this one. I said, okay, the file didn't go through. I'll send it in another 2 hours. My mentor was telling me, Janaka, for you, it's about a file going out. For an old lady sitting in a senior home, that is her rent not being paid. So there's a clear difference. For us, it's a file that we generate and it doesn't go through. And adding something on top of something you mentioned, Kumaran, the reason why I am very serious about this NFRs is because in ISA, remember, we have the 4+1 view.
Yep.
This is something I have inculcated the team to follow to the T to the dot. Because if you follow that pattern, that modeling, all these things become very important very quickly. And the thing is, I think it is a very difficult discipline to master. But if you get the team to follow that pattern, because I like that one, because the thing is, it encompasses, when you start filling it from one side, it will start contradicting the other modules, and then you will keep on enriching it. This is something we have learned in the architecture training, which I use. I think the resiliency aspect also falls into that one as a quality attribute. What you said was correct. So that's for me, a small tip for me is that if you want to think about resiliency is part of that 4+1 modeling process that we do, and then it becomes very organic.
Nice.
Because it ties into all the 5 views, right? For example, you have the business case, you have the deployment, you have the logical, and you have the component layout. Because resiliency basically, it's like a feature that attacks all those 5 quadrants.
Got it.
So
okay. So thanks, Janaka. I think
Kumaran, I need to run off now. Yeah. Okay. So, thanks, guys. Deepak, Venkat, Raja, nice to meet you. We'll catch up slowly. Yeah. Okay. Take care, guys. Bye-bye.
Thanks.
So, Raja, do you want to share in your thing where you had seen?
Sure. Okay. So I just talk from an architect hat. Okay. So the resiliency is right from the beginning. I don't see this as a new thing that's coming up, but the MTS, because the first exposure to me on Microsoft is actually MTS servers, the Microsoft Transaction Servers. So it starts from there, almost like the early late 90s and early 2000s, right? So always software industry was trying to solve the problem, right? As you rightly said, Kumaran, right now, the only peacefulness that we get as an architect is resiliency, because the cost of it is reduced so drastically. So one of the trade-offs that we can just put it as a standard item is actually resiliency. When I compare it to the performance, or when I compare it to the usability, the accessibility, maintainability, and all those stuff, right? The quality attributes. One of the things which keeps peace of mind for me is actually resiliency, because of the technology advancement that we have that is evolved for this particular aspect of quality, right? The attribute, especially on HTML5, where the parts of the screens can be going wrong and still your application is not down. This kind of technology is not available before, right? In the UI aspect. Similarly, from an the component aspect, right? So if one of those services is down, automatically the same service is going to run repeatedly. It automatically self-starts itself, right? This kind of technology, we haven't done this before, actually. So that's the peace of mind I see from a resiliency point of view. Right now, the technology is so evolved. Thanks to Google for SRE, the separate topic they have created, right? The site reliability engineer and the engineering aspects to it, really the engineering aspects to it. That gives a lot of peace of mind as an architect for me, where I can make this as a standard. This is what we have to do. Similarly, like how we put functions in the code, this has become a standard. So I don't have to break my head so much on this particular quality attribute henceforth. That's my point of view, mainly because of reduction in the cost in this.
Nice. Okay. Venkat, you have.
Yeah. Yeah. Yeah, rightly, Deepak pointed out. So resilient, we need to be developed at the time of designing the requirement itself, right? Like at the time of coming up with the requirement itself. So and we need to consider every single function it may fail. I'll tell you one example. And when I was talking to my one of my friend, so they were building a one software. So they are handling the claims requests. So and based on the buy and sell, some you can share. And at the end of the week, they have to show the reports. Okay, these are the things you bought and these are the things you buy. So then and one week they have come up with $1 million is difference, but they are bought, but they have sold it. And they come, then they find out that one developer, they just copy and pasted one code in the sell part instead of buying. So they are saying that they are buying something, and in backend they are selling it. No one knows. So
Okay.
it was a 1 million loss for them. So and one important aspect, the resilient we are talking about right now, is the technology is supports very easily. When I say when you go to the Gmail, it's showing you are in offline, but it's still allowing us to use the app, right? So that is the important what I see it very useful feature, and being everyone should be adopted. So yes, so in our and in our app also, I could say one example. When we are trying to build the app, we built it and shipped it, and we got from the customer point of view, they are saying that this is not working. They're simply saying it is not working, it is not usable, because we haven't understand our customer point of view, because in their in our customer, most of them, they're working at the farmer, they are having only 2G and 3G. So it is not loading it properly. So then we implemented the offline support. Then we are making sure that when there is no internet also, it has to be work, and it has to be synced when the internet is available. So this one, we supposed to incorporate this functionality at the time of capturing the requirement itself, not at the time of testing with after the production is gone.
So which feature here requires more resiliency than the other? Did you have any distinction between this service I will have resilience, or this feature will have resilience, this need not have resilience, like that?
Okay. So for example, in our case, whenever the AOs, is the aquaculture officers, they will go to the farmers and they will record the meetings. So for his point of view, the customers he has assigned is a fixed. It should be resilient, and he could able to capture the meetings. This is also should be a resilient. These are the 2 points is very important. Other than what are the points we are generating a report, this and that those points need not be resilient.
Need not be resilient. Yeah. Sure, got it. Nice points.
These are the 2 points.
Deepak?
So I already gave my points on resiliency, and
any application that you said they've done it smartly, or it's inspirational from what you have seen, how they have done that?
So I can't remember from the top of my head where they have implemented, but I have seen failures of resiliency quite a few times to do, which could have been prevented if the architects had understood how to apply that technology to their advantage, right? And the solutions were fairly simple, right? It's not like it required a huge amount of sort of resources or technical knowledge to do it, right? Simple things like what I mentioned, having retry built into your microservice, right? Which is like, if it is talking to some other service and it is dependent, it is across the network, it can, the latency can be added because of whatever reasons, right? And cloud makes it actually even more important for the architects to understand what are the possibilities of resiliency, right? Because you could have geo redundancy, which will add to latency, how the things will behave. There are too many factors for them to consider. And one point which Raja made about site reliability engineering, which means if you have not heard about it, it actually is software engineering applied to operations in that sense, right? So that's what it originally was intended for from Google's perspective, right? So when Google invented this whole site reliability engineering thing, they were looking at how does a software engineer make sure that operations runs well, right? So what they are doing is the site reliability engineering is completely operational in that sense, that it's not really it's not expected that they will come and do your development for you. But what they do is they are looking at it from what happens to the applications in production, right? What is important, right? How do you measure stuff? How do you measure degradation of a service? All those things, they can feed it back to the people who are developing the application, right? They can participate, so they can even look at the code. That's the kind of experience they expect the operations people to have, right? So this is something which is unique to site reliability engineering.
So I just add a point to it, Deepak. So it started like that when Google started at about 2005, right? But last 5-6 years, now it's part of full stack developers. Actually, it's part of the squad. So if there is a squad, the squad will have this capability to ensure this engineering is also taken care as part of the code.
Yes, that's correct. That's correct. Means they are part of the team now, right? So in fact, the Microsoft has published a lot of its
operations anymore. The point I'm trying to
make it comes from there. That's my point was, it comes from there. They look at it from that perspective, right? That how it will work in production, in operations, right? That's what their perspective is, right? Although they are complete full stack developer, like you said, but their perspective is production.
Okay. So I think that was good. I think basically related to what Deepak said, one thing that actually struck me as an interesting thing is, with cloud, we can do very lot of simple things. Like one app which I saw, it's a mobile app, okay? Instead of it says fail or try, right? They actually give a pop-up with a HTML, which is a link to a WhatsApp. Contact customer service. Okay. Now, I think that was a very smart use of cloud technology today. Now, when you click that, right, you don't even subscribe to a service. It's absolutely free reliance you get, literally. Resilience. Okay. You click that, it'll just open up WhatsApp with the number of this contact here. So the customer is not left in a lurch. Maybe not something ideal, but the business continues. He says, I was trying to get a bank account balance, I couldn't get it. Whatever be the question, right? You just leave it open. And it is literally zero. Probably you have to write that too. See, anyway, I'm going to show a message. Say, please wait, system down. Instead of that, it'll say, having a problem, contact our support. Click that, it will open on WhatsApp. Okay, so our application is still functional, technically speaking. Okay, not the perfect thing, but it's a downgraded solution, but my application is still up. It is just not down.
Yeah,
I think
so
there is
one more perspective there, Kumran, right? So 5-6 years back, we used to get that message itself, right? So just a message, right? Now this message will happen after 6-7 times something happening in the code. Before that, it's the next step. Now it's 7 steps down the line to show the message, and these 7 steps are actually part of the reliability engineering to make sure somehow we do this transaction within the system, right? And it's taken care as part of the code. That perspective to the squad and that perspective to somebody coding that functionality is what that is
that's a
becoming.
great point, Raja. I think my thing was what I call as a poor man's resilience. With cloud, we can do that. You need not have a, I mean, like, yes, we should, but till especially small teams, transitioning teams, growing teams, right? There are very simple things with bare minimal technology, skill, and cost. You can still get it today's world, but we just need to start thinking in that aspect. Now that WhatsApp thing is which I'm thinking I'm going to use in my apps. I practically don't need extraordinary skills. I just have to tell my developer, hey, wherever you are telling, please wait, put this link. That's all.
Absolutely.
Okay, I have introduced so I'm resilient not from a technical or a app perspective, but I'm resilient from a business perspective, which is what actually matters. So it's kind of interesting. Great discussion. Thanks for all your insights. We will catch you in a fortnight from now.